In this particular video, we are going to discuss about GATE 2023 questions of subject computer network. So you can see the first question is on your screen, that is, suppose two hosts are connected by point-to-point link and they are configured to use stop and wait protocol for reliable data transfer. Identify in which of the following scenario the utilization of link is lowest. We need to check that in which scenario utilization of link is lowest. Okay, so what we can do here, first of all, we need to find out what is the link utilization or efficiency. The meaning is same. So for the stop and wait protocol, the formula for the efficiency is what? Tx upon Tx plus 2Tp, where Tx is what? It is a transmission time, and Tp is what? It is a propagation time. So what we can say about the Tx? So we can say that Tx is simply length by bandwidth, length of data divided by bandwidth. And what is Tp? So we can say that for the Tp it is simply propagation delay. So distance divided by speed. Okay, so distance divided by speed. Here L is length of data divided by the bandwidth, length of packet divided by the bandwidth. So let's say here we can say that efficiency is equals to 1 upon 1 plus Tp by Tx. Okay, so 2Tp by Tx. Now, so according to that, what we can say, 1 upon 1 plus 2 into what is Tp? Tp is what? It is D by V. Okay, and what we can say, what is your Tx? Tx is L by B. So L is here and B is there. Okay. Now in question, what we want the link utilization low, means we want low efficiency. So when low efficiency is low, so we can say that simply if denominator value is high, then efficiency become low, and if denominator value is high, so in that condition, when we can say that the denominator value is high, so simply if you want to increase that value, then your efficiency become decrease. Okay, so what we can say, we need to increase the bandwidth, so bandwidth is need to increase, means higher transmission rate. Okay, and what we can say, transmission rate should be higher, and that would be the distance. So what we can say, efficiency is inversely proportional to distance, means you want to decrease the efficiency, then you need to increase the distance. So what we can say, longer link length. So D and B, we need to simply we can say that efficiency is inversely proportional to distance, as well as it is inversely proportional to bandwidth. So simply we want to reduce this thing, so we need to increase this both the things. So what we can say, we can go with option B. B is your answer. Got it? That is, a keyboard is connected to a computer used at a rate of 1 keystroke per second. Okay, so 1 keystroke per second. The computer system poll keyboard every 10 millisecond to check that keystroke, for a keystroke, and consume 100 microsecond for each poll. If it is determined after polling that a key has been pressed, the system consume additional 200 microsecond to process the keystroke. Let T1 denote the fraction of second spent in the polling and processing the keystroke. In an alternative implementation, the system uses interrupt instead of polling. An interrupt is rise for every keystroke, and it takes only 1 millisecond for servicing the interrupt. Okay, let T2 denote the fraction of the second spent in the servicing the interrupt and processing the keystroke. So we need to find out what is the ratio of T1 and T2. So we need to calculate the time spent by the first and time spent by the second implementation. Okay, so here what we can say, first of all, you should check here what is the polling time. First of all, we check here what is the polling time. We need to calculate T1. Okay, so see, for T1, for polling time, what to do? So first of all, you should remember one point here. The point is what? Time spent in polling, time spent in polling is what? Time spent in polling is simply, as we know that keyboard stroke is in every 10 millisecond, it is given that. Okay, computer system poll keyboard every 10 millisecond. Okay, so poll is done in every 10 millisecond. So how many polls we can do in 1 second? How many polls we can do in 1 second? So what we can see, in 1 second is equals to 10,000 millisecond. In 10 millisecond we can do one poll. So can we say that we can give 100 poll in 1 second? We can give 100 poll in 1 second. Now see, 100 poll in 1 second, and we know that it consumes 100 microsecond for each poll. So time spent in polling, we need to do 100 polls in 1 second, and for each poll the time spent is 100 microsecond. So how much it is? Can we say that it is equal to 10 millisecond? Okay, so time spent in polling is simply 10 millisecond. Okay, so that would be the time spent in polling. Now to processing the key stroke per second, we require 200 millisecond. So for key stroke, the time is what? 100 microsecond. For t it is 100 microsecond. Okay, now what we can see, 100 microsecond, not 100 microsecond, it is given that additionally 200 microsecond for the processing keystroke. So it is 200 microsecond. So for 200 microsecond it is what we can say, 0.2 millisecond. So what we can say, the total time T1 is what? Time spent in polling, that is 10 millisecond, plus the additional delay, that is 0.2 millisecond. So how much it is? It becomes 10.2 millisecond. So the value of T1 is 10.2 millisecond. Okay, just see here, the value of T1 is what it is? 10.2 millisecond. And here it is clearly given that if we are going to implement alternative implementation, then it require 1 millisecond. Okay, so simply what we can say, for this keyboard interrupts, so the value of T2 is directly, we can say that it is 1 millisecond, just T1 by T2, so it gives you answer 10.2. so that 10.2 is your answer. Got it? Now see the next question. Suppose you are asked to design a reliable byte stream transfer protocol like TCP, and you rename that as a myTCP, that runs over the 100 Mbps network in the round trip of 1 millisecond. Okay, so round trip is 1 millisecond and it runs over the 100 Mbps network, and the maximum segment life is 2 minute. Okay, so which of the following is the valid length of the sequence number in myTCP header? So let's see here, in that condition what we can do, simply first of all you should check that the given bandwidth is what? It is 100 Mbps, means 100 MB data we can transmit in 1 second. Okay, 100 MB data we can transmit in 1 second. Okay, so how much data we can transmit in see how much data we can transmit in 2 minutes. So let's see, it is 100 M bits. Okay, 100 m we can write 10 to the power 6 and it is in the form of bits. So if we want to change that in terms of byte, then we need to divide by 8. Okay, so when we are going to divide this by 8, so it is 125 into 10 to the power 5 bytes we can transfer in 1 second. So how much data we can transfer in a maximum segment life is what? It is 2 minutes. So how much data we can transfer in 120 second? So simply 125 into 10 to the power 5 multiply by 120 byte. We can transmit that much data. So on calculating this, the value become 15 into 10 to the power 8 bytes we can transmit in 120 second. So if you want to transmit that much amount of data, okay, we want to transmit that much amount of data, so just you need to calculate what is the length of sequence number. So sequence number should be greater than equal to log base 2 that specific value. So we need to take log of this. So on taking this, it is equivalent to 31 bits. Okay, so sequence number should be greater than equal to 31 bits. So 32 is also possible, 34 is also possible, and 36 is also possible. So we can go with this three option: 32, 34, 36, all are correct. So BCD is the correct answer for this particular question. Now see here the next question, that is, suppose in a web browser you click on the www.gate2023 URL. Okay, see here there are total 4 options. So first 2 options are written here. There is a option C as well as option D also. Okay, ultimately we need to check that how many RTTs in case of non-persistent HTTP and how many RTTs in case of persistent HTTP. We need to check that particular thing and accordingly we need to give the answer. Okay, now so option C says that 9 RTTs in case of non-persistent HTTP with 5 parallel TCP connection. Okay, and option D says that 6 RTTs in case of persistent HTTP with pipelining. Got it? Let's see here. Now see the question. Suppose in a web browser you click on the www.gate2023.in URL. The browser cache is empty. The IP address for this URL is not cache into your local host. So a DNS lookup is triggered, okay, over the 3-tier DNS hierarchy in a iterative mode. No resources recorded are cached anywhere across all the DNS. Let RTT denote the round trip time between your local host and DNS server, in the DNS hierarchy. The round trip time between the local host and the web server hosting is also equal to RTT. The HTTP file associated with the URL is small enough to have negligible transmission time and the negligible rendering time by your web browser, which refers 10 equally small objects on the same web server. You need to check that which of the following statements are correct about the minimum elapsed time between the clicking on the URL and your browser fully rendering it. 7 RTT in case of non-persistent HTTP and 5 RTT. There are different options. So ultimately we need to focus over 2 things. The first is what? The first is if we are doing for the persistent HTTP, okay, and second is for the non-persistent HTTP. So let's see, in case of for persistent HTTP with pipelining. Okay. So persistent HTTP means what? TCP connection is established only once and multiple files you are transmit in a single connection. That is the meaning of persistent. Means once you need to establish the connection, and after then you can transmit the file, multiple files you can transmit in a single connection. The second is what? We can say that for HTTP with pipelining. So what is the meaning of pipeline in this? So meaning of pipeline means that the new HTTP request could be sent to server without receiving the acknowledgement of the previous request. Okay, so we can send the new request without receiving the acknowledgement of the previous request. Okay, so let's see here. For this, what we can say, supposed to be there is a client and server. So there is a request 1. Then we can send another request also without receiving the first acknowledgement. Then we can receive the acknowledgement 1, and then we can receive the acknowledgement 2. Okay, so what we can say, the host, first of all, what will happen? The first thing is what? So the host will connect with DNS server to resolve the domain name and getting the IP address. So in this it requires 3 round trip time. Okay, so first task you need to do the contact with DNS server, resolve the domain name and getting the IP address, 3 round trip time. After that, now client establish TCP connection with the gate 2023.in server. Okay, so after then it should establish the connection. So that establishing connection require 1 round trip time. Okay, and after establishing connection, what we can say, now client send HTTP request to get the base HTTP file and receive it in the 1 round trip time. After that it need to do this thing. Then fourth, now client send HTTP request for object and receive all the 10 objects in 1 round trip time. Okay, so that would be the total things. So what we can say, how much is total addition? 3, 4, 5, 6 round trip time is required for the pipelining. Okay, so according to that we can go with option D. D is correct, but it is MSQ question, so we need to check for non-persistent HTTP also. So let's see, for non-persistent HTTP, what we can say, here we can say that we need to make a TCP connection for each HTTP request and then we need to close it. Okay, and here we need to make a 5 parallel connection, because in both the option it is given that the 5 parallel connections. Okay, so 5 parallel connection means what? 5 objects could be sent parallelly at the same time. Okay, so we can send 5 objects at the same time. Let's see how it goes. So in first, what we can say, we need to resolve the DNS. So DNS resolution, as we know that it take 3 round trip time to make a connection to resolve the name. Okay, then we need to make TCP connection. So to establish TCP connection we require 1 round trip time. After making TCP connection, getting HTML base life, it require 1 RTT. After doing that, we need to establish TCP connection again. We need to establish TCP connection, it require 1 RTT. Okay, after doing that, getting 5 objects parallelly. Okay, because we are doing the 5 parallel connection, so 5 parallel objects getting again require 1 RTT. After doing that, what we can say, we need to establish TCP connection again. We need to establish, every time we need to establish this connection because it is non-persistent, so it require 1 RTT again. Then what we can say, 1 RTT for getting remaining 5 objects. Now we can total we need to access 10 objects, so 5 in this parallel, and again we need to access the 5 parallel objects, so it require again 1 RTT. Okay, so what we can say, we need to make a connection before getting HTML based live. before 5 parallel objects and before 5 parallel objects. So what we can say, the total is 9 RTT. So 9 RTT is your answer. So what we can say, C is also correct. So we can go with option C and D both. Got my point? So these are the questions from the computer network, and there is one more question from the computer network related to the concept of IP address. Okay. See here, what we can say, there is a packet address destination. This is arrived at the router. It will be forwarded to which interface ID? There is interface 1, 2, 3, 4 and 0. Okay. So if it is matched, then we need to transmit with this, otherwise we need to go to the default. Supposed to be there is a more than one matching, so in that condition it choose the longest prefix match. Okay. So for that what we are doing, so simply you need to do one thing. Let's see here. First we need to check with the interface 1. So in that condition what we can say, 200.150.68.118, that would be the destination packet address. Okay. Now this address is ended with the interface 1 subnet mask. Okay. Interface 1 subnet mask, that is 255.255.255.0.0. So what we can say, it is 200.150.0.0. So what we can say, it is matched with its subnet. So there is a matching, it is matched. Let's check with the second option, 200.150.68.118 and 255.255.224.0. You need to take a binary of this two segment, and then you need to perform the operation between them. AND operation you need to perform. So AND operation gives you 200.150.64.0. So again what we can say, it is matched. Again it is matched. Let's transmit with C. It is what? 200.150.68.118, okay, 255.255.255.0. You can clearly see here 118.0 is 0 only. This is 255 means all ones dot 68. So it gives you the 68, it gives you 150 and it gives you 200. Again it is matched. So what we can say, it is matched with the first one, it is matched with the second one, as well as it is matched with the third one. Let's try for the last one. So 200.150.68.64, okay, and is matched with 255.255.255.224. We need to do the AND operation with this. Okay. So after getting the AND operation, it gives you 200.150.68.96. Okay. So let's see here. Here what we can say, this is not matched. So it is matched with first three options, then it check the longest prefix. So this is the longest prefix that is matched. So we can say that 3 is your answer. Got it? So these are the questions from the computer network topic that asked in GATE 2023. Thank you so much.